This is Saturn's most beautiful ring, but it's also one of its strangest. It's called the E-ring, and new research suggests it may be a lot more dynamic than we thought. We've known for a while that the E-ring is constantly being replenished by geysers on the icy moon Enceladus. But how does such a delicate structure remain stable for millions of years? The answer could be hiding in some very unexpected places. This is the E-ring. And if you're asking yourself what I'm talking about, don't worry, you're not alone. Most people have never heard of this ring because they can't see it with the naked eye. It's way too thin. In fact, the E-ring isn't even really a ring. It's more like a cloud of ice particles that extends over 2,000 kilometers from Saturn's middle to its outer edge. Now, because it's so thin, it's very hard to study. And because it's made of ice, it doesn't reflect much light, making it even harder to spot. So we still don't know exactly why it looks the way it does, or even exactly what's in it. But we do know that it's constantly being replenished by water vapor and ice particles spewing out of cracks in Enceladus' crust. These are called geysers, and they were first spotted by NASA's Cassini spacecraft back in 2005. At the time, scientists had no idea where the water was coming from. So they started calling the geysers cryovolcanos, cryo meaning ice volcano. They didn't actually erupt like volcanoes, though. They just sprayed water into space. It took another decade for us to figure out that the water was coming from a vast ocean that's hidden beneath Enceladus' frozen crust. We figured this out by measuring the chemical composition of the water vapor plumes. They were almost entirely made of water molecules, unlike the plumes of other cryovolcanos, which contain all sorts of other molecules like methane, ammonia, and carbon dioxide. Now, the reason why this ocean water is being shot up through the cracks in Enceladus' crust is still a bit of an open question, but we think it has something to do with the gravitational tugging of Saturn's gravity and the tidal flexing that goes along with it. Basically, as Saturn and the other moons orbit each other, their gravitational tugs stretch and squeeze Enceladus. This creates heat, and that heat melts the ice beneath the surface, creating pockets of liquid water. Then, when those pockets of water reach the cracks, they're forced upward. Think of it like squeezing a toothpaste tube. That's the simplest explanation anyway. And it makes sense considering that Enceladus has more than 100 known cryovolcanos, and they all located near the equator, the part of the moon that gets stretched the most by Saturn's gravity. But as cool as these geysers are, they shouldn't exist. Well, at least according to our understanding of physics. See, the E-ring only exists because Saturn's gravity keeps the ice particles suspended in midair. And for that to happen, the particles need to be extremely tiny, less than 1 micrometer across, which is about 1/100th the width of a human hair. Unfortunately, the ice particles created by the geysers on Enceladus are anything but microscopic. They're tens of micrometers wide. So it seems like the particles should just fall straight to the planet below them instead of forming a ring. Plus, the E-ring is 2,000 kilometers away from Enceladus, and it doesn't seem likely that the geysers could fling particles that far. So the real question is what happens to the ice after it leaves the geysers? Does it just float off into space? Does it fall onto Saturn? Or does it somehow magically shrink down to form the E-ring? Well, it turns out the answer might be yes, all of the above. And the key to understanding how that's possible is a little understood process called coagulation. Imagine you have a bunch of really tiny ice crystals floating around in space. If they collide with each other under the right conditions, they can stick together and grow larger. In theory, this is exactly what happens with the ice grains in the E-ring. The only difference is that the conditions needed for coagulation are usually way too cold. But here's the thing, the plumes blasting out of Enceladus's cryovolcanos aren't just balls of ice, they're balls of ice mixed with tons of dust. And that dust is super hot, thousands of degrees Celsius hot. So when the dust hits the cold ice crystals in the E-ring, it heats them up, enough that they become sticky and start colliding with each other. And if they collide under the right conditions, they can stick together and grow larger. Now, technically speaking, there's more to it than that, but that's the basic idea. The dust carried by the geysers heats up the E-ring enough that the particles can coalesce, eventually forming microscopic grains. And the best part is that this process should get stronger the further away you are from Enceladus. That's because the particles in the E-ring are exposed to more and more dust as the geysers blast it outwards. So the particles further away from Enceladus should be smaller than the particles closer to the moon, which is exactly what scientists observed. So it looks like we finally understand how the E-ring manages to stay in one piece for millions of years. The dust carried by Enceladus's geysers gradually heats up the ring, causing the ice particles to coalesce and form microscopic grains. And that's why the E-ring is one of the most delicate structures in the solar system, or it would be if it weren't for one thing: Saturn's wines. See, although the particles in the E-ring are small, they're still big enough to be blown around by Saturn's insanely powerful wines, which can reach speeds of 1,800 kilometers per hour. And that means that the entire ring is constantly shifting and changing shape, moving from the inner edge of Saturn to the outer edge and back again. Luckily for us, though, Saturn's wines don't blow fast enough to completely blow the ring apart. If they did, the E-ring wouldn't be able to survive for millions of years. It would just get destroyed and dispersed into space. Now, scientists have known about Saturn's wines for a while, but until recently, they had no idea how they were affecting the E-ring. That's because they couldn't see the ring in high enough resolution to spot any changes within it. But thanks to some fancy machine learning algorithms developed by researchers at the University of Berlin, we can now analyze Cassini's images of the E-ring in unprecedented detail. And what they found was pretty shocking. The E-ring isn't static at all. It's constantly shifting and changing shape due to Saturn's wines. In fact, it's actually made up of two rings. There's the bright western ring and the fainter eastern ring, and the two rings move independently of each other. The western ring moves like a wave, expanding outward from Enceladus every 26 days before being blown eastward. Meanwhile, the eastern ring remains fairly stationary before being swept up by Saturn's wines and disappearing. So it looks like Saturn's wines play a bigger role in the E-ring than anyone expected. Not only do they prevent the ring from getting too wide, they also help keep it fed by bringing fresh material from the west to the east. And who knows, maybe they'll blow the whole thing apart someday. Of course, if that happens, it'll take a lot longer than 1 million years. You know, it's funny. When I first read this paper, I thought it was gonna be boring. Like, come on, who cares about a ring of ice? But then I started thinking about all the crazy stuff we learned about the E-ring in just the last few years. First, we learned that it's powered by a vast ocean beneath Enceladus's icy crust. Then we learned that it's constantly being replenished by microscopic ice grains formed during a process called coagulation. And now we're relearning that the entire ring is constantly shifting and changing shape due to Saturn's wines. My point is the E-ring is way cooler than I thought it was. And now that I think about it, I'm kind of disappointed I never noticed it before. But hey, at least we have Cassini and the talented engineers and scientists at NASA who made it all possible. Because without them, we'd still be sitting in the dark wondering what the heck the E-ring is. Thanks for watching this video, guys. If you liked it, check out our other videos, and if you love it, hit subscribe.